The other day I was trying to make a video on how to emulate a computer using PCem and installing MS-DOS. And the software PCem is available in FreeBSD, but I found out that it's buggy. So I decided to investigate what the problem is and try to fix it. In this video I'm going to show you how I debugged the buggy program and how I made it work. And hopefully this information will give you some insight in case you need to do something similar. So let's first try to download the original software for PCem. PCem is available on the following website under the development. We go to the GitHub page, and here we have a link, and I just create a directory that I'm going to call PCem, and I'm going to clone the project. The version that is available in FreeBSD is version 17, and I'm going to use exactly the same version that is currently in FreeBSD. For that I do a git check out version 17. You need to check which tag is being used for the project, for the software that you want to look at. Here I use version 17. Let's have a look at the files. This is how the directory currently looks like. I like to see some colors. ls fng. This looks good. And the first thing that we need to do is that we need to install the auto-reconf, which I've done it already in my system. And we need to make sure that the system is using C and CC, that it's using the local compiler CC and C++. And for that I do an export CC equals small place CC and export CXX equals C++. So the first thing I'm going to do is to do an auto reconf and -f and -i so that it takes the settings. And now I'm going to do a /configure, and now we see the first problem that it says the CPU is not supported. This problem actually comes from the configure AC file. So where do we have the CPU? We have the CPU being set here. So we need to add or AMD64, which is also the same kind of CPU. Then we do again another configure. Sorry, not that one, an auto reconf, and now a configure. Again, another issue that we find here is that it's complaining about the WX widgets, and it needs the WX config, but this is installed in my system. So let's have a look. What is the command that we need to use? This is with the WX config, and the WX config script to use. Which one do we have? WX config is this one here. Looks okay. The WX something config. And this means that we need to do a configure with the parameter equals to this one here. Let's try. It ran through. Looks good. Gmake, I have 8 cores in my machine, so I'm going to push for 8 cores. And it's starting to compile. Now, okay, I can stop it already because I'm seeing some errors. And the first thing that we see is that we have undeclared identifier, prot_read for mmap. Let's open another terminal and try to see mmap. Mmap needs the sysmman, needs this include. This is being done here in this file. So let's try to find, find name this file. It's under the source directory. I'm going to go here in this terminal, so vim source with this file here, and we see here the mmap. It's being used here. And the other thing, if we go to the beginning of the file, that we notice is that we have if defined Linux, if defined Apple. Of course, FreeBSD will not have Linux defined, and therefore we are not including the sysman, mman. I'm going to search for _Linux in all the files. There are a couple of them that have the defined symbol. The first thing I need to do is I'm going to get only the file names. So I'm going to search for something starting with a semicolon and anything else. I'm going to strip it away. We get the file names, but they are repeated. So I want to get the unique values, only these files here, and now I can do an xargs and pass all these file names into vim. Now it's just hand work. I do defined here FreeBSD. Next file, and we are at the last place. Again, let's try to compile the software. And here we see some additional trouble with the fopen call to undeclared function. Let's see, man fopen 64 doesn't exist, but this function can be simply replaced. So I see the tell seek, open. Those functions can be simply replaced with their equivalent, with the fopen without the 64. So here what I'm going to do, first I need to close in this terminal, in this tab, the keyboard is going a little bit crazy. I don't know why. Grep, so fopen 64. Let's search for this. Okay, seems that it goes through. We can execute the PCem directly from the console, and here we see that we get a segmentation fault with a core dump. So we're not done yet. What can we do to debug this problem? Configure. Let's have a look here on how to enable debug. So let's do again a configure, but with debugging enabled. Gmake clean, and let's recompile everything. This program is relatively small, so it doesn't take too much time to compile, which is good. Otherwise this video would take definitely lots of time. Looks good. PCem. I didn't expect anything different. It's a segmentation with a core dump. The core dump is a file that is here, and I'm going to use the core in order to get the symbols. So gdb to get the exact location where the problem occurred. So we can call GDB with the executable and with the core file, and this is going to allow us to have some really good visibility into where the problem occurred. The problem occurred exactly at the block right here. This is at code gen add byte. Let's do a backtrack. So this is this file here that comes from this file, and etc. If you poke a little bit around with this, so since I've done this already before, I can definitely tell you that the problem is happening in the mmap function. Let's have a look. I think it was in the code gen. There is a code gen with an allocator. So mmap. The problem that we have here, we're doing an mmap and then trying to access the memory to write something. This mmap is going to give some properties, special properties to this memory block: read, write, and execution. And it's a anon. If we look here into the manual, the anon tells us that map anon maps anonymous memory not associated with any specific file. The file descriptor used in creating must be -1. The file description must be -1. And if we go here, this is the FD, the file descriptor, and we can definitely see that here it's 0. So this is not correct. Let's fix that. And again, going to this part, just to make sure that everything is correct, I'm going to search for an mmap with an anon, pipe grep anon. Okay, we have a couple of things. So we see here that in this file we also have an mmap with anon with 0. The allocator we have here, and in the okay. So in which files do we have? Set search this anything. This didn't seem to work. Yeah, doesn't matter. Let's just try to do the things by ourselves. Here, anon. With the anon, it must be -1. It's the only place where we have the anon. Which other places do we have? So let's see here. Here this is -1, this is -1, and this is still not done. So let's have a look at this file. And here we see also some issue. So all the files now should hopefully have... okay, now I see. Now I see why it didn't work before. I needed a star. But actually now I need to see the thing. So, so everything is fine. And now let's try to recompile. Gmake clean to make sure, and J8. And now let's try to run the file PCem, and look, we have a configuration manager. This looks good. Now let's try to create a virtual machine. Going to create some tests. Okay. Let's start with a simple machine. We're going to go for what kind of machine? A word BIOS, 486 should be okay. 16 megahertz. Let's put a really good one with a 50 megahertz or a 66 megahertz. 32 megabytes of RAM. That, and back in the time this was quite a lot of memory. Let's just put 16 megabytes. That's already quite a good thing. CGA graphics, that's not so great. An S3 Verge was a nice graphics card. For sound, we don't put any card, we could put some Sound Blaster. For the floppy disk, we put 3.5, and here none for the second one. I can leave the CD-ROM here, the standard. Okay. Now let's create a hard drive. So a new drive, and let's go for a really nice one. By then, computers started to have problems. There was some time where if you had a hard disk that was more than 500 megabytes, you could get into trouble, because the BIOS was, the original ones were not really that keen on such a hard disk. Whoever needs more than 500 megabytes? Actually, the saying was, who needs more than 640K? Well, let's just limit to 500 megabytes. Should be good. New file. Let's put this into this folder here, and let's just call it HDD 500M, something like this. Okay, this is plenty of space. Drive created. Do not forget to partition. The mouse is a Microsoft mouse, joystick. Well, no network card. Looks good. Let's boot up the machine. And we have another core dump. Where is the core dump? Let's try to see the core. And we have here some problems with ATA-P. So this is a CD-ROM issue. And let's print the ATA-P. It's a 0. Of course, we should not be dereferencing null pointers. Actually, backtrace. Do we have a file name? Yeah, it's the id.c. Let's try to fix this. So actually here, so find ide.c here, but I'm going to do something a little bit better, which is I'm going to grep for ATA-P anytime I want to dereference the ATA-P here. So let's see where can we have some issues. We have lots of things in the IDE. On the PC is also there some dereference for stopping in the SCSI part. And hopefully here at this part there should be no nulls when we do some sector reads, etc. This would be pretty bad. Here, SCSI, maybe we can fix some places here. Stop and exit and so on. So let's see. Let's start. Let's start from the beginning. Let's go for the IDE, which was where we observed the problem. And ATA-P here, I'm just going to say if ATA-P, then we do something like this, so then we can stop it. The pointer is just being dereferenced without checking for null, so that's not good. Now they are all looking at this. This doesn't really look like a big issue. I'm just going to leave it there. Recompile. And rerun. Okay, start the machine. Here I'm going to say the video output scaling 2 times. We can see it a little bit better. Now, as we can see, the machine is actually powering up, so it's looking pretty good. the secondary master should be the CD. It says none. Checksum default load. Okay, checksum error. Let's try to go to the BIOS. Auto. So here we definitely need to say that this is 1.44. Boot sequence A and C. Looks good. Chipset features, I don't care for this now. PC, also load defaults, save and exit. So right click, let's eject drive A, so actually there is nothing. Change drive A. Let's try to see if the machine can boot my floppy disk. Yes, starting MS-DOS. Remove all the disks, so disk eject, and hopefully now we can boot from the hard disk. Let's see how this goes. This is nice. So what is the version that we have? MS-DOS version 6.2. Let's try to install some additional things. Non-system disk. This is interesting. Probably because I need to eject drive A and I forgot about that, and just press enter. Yes. This was also back in the day. If you leave the floppy inside, then it's going to try to boot from the floppy. You have one floppy in the drive. How did we start? We started with Win. And here we go. Nice. Games. Seems that the simulator is this emulator is now working properly. I never liked the draw 3, draw 1, and we can start playing some solitaire. Here, etc. Okay. The Minesweeper application. Last, I wanted to show, so I'm not going to look at the CD now. What I can tell you is that from experiences I've done separately, the BIOS sometimes has some problem identifying it, but it does work in the machine. So, but the last software I would like to show. Installation complete, and XtreeGold, and this is XtreeGold. We can type in star and it will load everything. So we can see Windows and System. Windows only had a subdirectory called System. Nowadays it's full of subdirectories. Let's say Control T. I think yes, these ones are also there. And now show all tagged files. Windows installed in an amazing 17 megabytes. You can see my disk is 500 megabytes. That's pretty big by the time. And Microsoft Windows is occupying, from the 500, it's occupying 20 almost 20 megabytes. That's pretty much. It was a pretty large software. XtreeGold. This is the way I used to. This is the way I remember. Yes. So we have the PC emulator working. We basically fixed it. And we have a really nice program here. If you want to go back to some memories, you have some old software that you'd like to run from MS-DOS. You can either use DOSBox or you can use the PCem. The difference with the PCem is it tries to be really close to the hardware to really simulate the machine. Thanks for watching. Questions and comments please down below. And I hope you enjoyed the video. Wish you all the best. Bye bye.